Welcome back, my fellow duplicants, to Oxygen Not Included. Today we're taking another look here at the sour gas boiler. Now, the last time I made this was for the sake of making sulfur. However, at the very moment I posted the video, Clay released an update adding a liquid sulfur geyser to the game. So before we go and look at this system here, which is kind of refined based on some of your recommendations, let's just take a look at that geyser to see how it compares to something like this sour gas boiler. So let's take a look at the liquid sulfur geyser that they added to the game. I found it on this planet right here. Then I found this and uncovered it on the map. And as we can see here, this thing puts out quite a bit of sulfur, although it is putting it out at a relatively hot temperature. We got 162 degrees Celsius. It makes sense to possibly add a little bit of water of this, steam it up, or something like that in order to knock that temperature down just a little bit. Just so you know, geysers have kind of a range that they can work in, so it kind of depends on where it's at. I don't know the upper and lower limits, but this one here that we're looking at seems to be quite active. And once I kind of worked through the whole calculator for this thing, so once I worked through the whole calculator here, I think what I've ultimately come up with is around 918 kilograms per cycle on average. One of the things here we can see is that this thing is active about 60 cycles out of every 90, so it's active a lot. And it looks as if one full tile of liquid sulfur is 740 kilograms. So again, if we were to collect everything here, we would need about 115 tiles for every time it runs through its full activity cycle. So that is that's pretty close to about that much liquid sulfur right there. Completely full. So the reason I bring this up is because if we were to compare this to what our sour gas boiler is able to put out, right now, this one particular geyser that I'm looking at right here is equivalent to about 10 times what I was doing in the last video. So if you're starting up a new map and you have one of these somewhere on your map, then that should definitely be part of your strategy for creating a sustainable system for your farm that requires sulfur. Now, if you don't have one of these in your map, but you want to actually add it, what you can do is if you have the debug tools enabled, you can actually go right here and you can actually select one of these. You might want to cover it up first with something like granite or whatnot. So I'll do that real quick. And then you can paint that so it kind of entombs it. There you go. And then if you use the selection tool right here, just like this, and then you come on over to save selection. I always just do one to kind of organize everything. And then I'll save that as sulfur geyser. So that'll actually be listed right down here in the templates. So the neat thing about that is once I have everything, we get past all the sort of defaults that are in the game, I can go right down here, find that sulfur geyser, and then paste it into the map. So if you're kind of bummed out that you don't have access to the sulfur geyser because you started your map a little bit before everybody else, then that's one way to get around it. Man, this one looks to be even more powerful. 63, 162. All right, so this geyser is actually a little bit less active than the last one, outputting only 828 kilograms per cycle on average. So there is a little bit of range there. All right, so after that, we can see that the sour gas boiler, while it is nice that we can get some sulfur out of it, doesn't necessarily outweigh the geyser or anything like that. We're never gonna beat that unless you build this thing to be enormous. So really, what I was trying to do here is come up with a design that really implements a lot of the ideas that we were having over here in the comment section underneath the last video and some things we were seeing on Discord. Again, there's a lot more comments and a lot more ideas floating around than I can even read. And I've also worked on the packaging. This isn't my first time redesigning this thing. I've actually done it several times to make some sort of blueprint that could actually be used inside of a base and possibly be functional. That's the idea. So it's very much on the same scale as what I had last time, just reworked. So hopefully it works a little bit better. To point out a couple of the ideas, one of them here was to possibly use the thermal nullifier to cool down sour gas, which I do have one in my base that might actually work out pretty good, although that's not what I'm exploring today. And then somewhere in here, if I keep scrolling, nope, that wasn't it. Aha! Here we go. Ryu was using a steam turbine on the inlet side over here to remove a lot of heat. That's one of the ideas that I'm actually going to be exploring right here. So that's this guy. As we know, it removes a lot of heat and converts it into power. So I've definitely put that right up here with the cold side out. And then I've repackaged everything over here on the right to try to make everything work together. That's the hopes, at least. All right, so let's plug this thing in and see what it can do. And if it works out, I'll explain it all to you. Let's start off with our heat source. The idea behind this is that this is kind of a set block. You just build this thing, and then your heat source is down over here somewhere. It doesn't really necessarily matter because you're mostly just going to pipe in your sour gas and get it to flow in right here. All right, so what I'm simulating over here might be something that you use to capture heat from a rocket. It is that 7x3 volume right down here. For this example though, I'm just going to go ahead and put some magma in there. And then to more accurately simulate something that might be coming off of a rocket plume, I'm going to go ahead and put a mechanized airlock right here, and this is going to be where I heat sink in the heat that I need in order to boil this stuff off. Here's where another idea showed up. The idea of using airlock doors over here to control how much heat we're pulling out of the crude oil that's flowing into here. You saw me use petroleum last time just to kind of I was avoiding any problems I might have with the crude oil. And it kind of had to do with not wanting to preheat that stuff a little bit too much. But to make this work and kind of work in a reliable way, what I really want to do here is to make sure that the crude oil doesn't get too hot. But I do want it to kind of be able to transfer heat out of here. So to make this work as intended, I think this is what I'm going to do. I have a couple of airlocks right there. I'll run the pipes through here so that they can actually conduct the heat. Maybe I avoid that spot right there. And then bring the liquid in right there. And the liquid in right here. The idea is that this thermal sensor will become active if we go above something like 350 degrees Celsius. Because we know that crude oil will turn into petroleum at 400. All right, so now let me just bring in the hydrogen. I'll just put that right there. And another one right there. Again, I'm kind of using this little trick here with the gas reservoirs in order to pre-fill up them just a little bit. One of the more interesting ideas I saw, again, with some of these ideas that people were throwing my way, was the idea of using metal tiles here and there to kind of even the temperature between the two lines of hydrogen so that it was nice and even going back into the regulators. I didn't find a good spot in my system here, at least a nice volume, in order to do that, so I'm not doing it. But if you wanted to kind of rework things to try that, I think that would be something you could do. Maybe you could push this off to the left a little bit here, and then put in a couple tiles right there and kind of work the pipe spaghetti a little bit more than I've already worked it in order to make that happen. Again, I don't really know how much of an effect that's going to have. All right, that's probably enough. Each one of these is going to be storing right around 70 kilograms of hydrogen. I've got this stuff up here set in just a little bit of oxygen, although it should probably take a little bit more than that. Yeah, there we go, about 1 kilogram or so. Okay, so let's get this thing fired up. First thing I'm going to do is turn that on real quick here so that we can actually let the gas flow on out. As you can see, the direction of the gas flow is this way. So that should be heating up nicely. Oops, and I noticed my first problem here. I can't put a sensor right there. That's kind of the thing about trying to convert this into like a package deal. You end up finding that getting everything to fit in a logical way tends to be a little bit of a problem. It's a fun problem. It's engineering, but in this case, I got to move all of this stuff over one tile, which means all of this needs to be redone. As you can see, it's definitely not my first time reworking everything, but that's the way this stuff goes. Sometimes you just need to delete and try again. You know, that's the whole idea of actually doing this in debug mode, to kind of develop your blueprint so that you don't end up mode and get everything built and find out that, oh, I was one tile off and now it doesn't work. So here we go. And in case you're wondering, yes, there will be pictures and stuff that you can copy if it works, mind you. All right, there we go. That doesn't look too bad. Not crazy about that pipe being out over there, but whatever. You guys were asking about this little dev generator. That comes when you have the sandbox mode enabled. You can take this thing and just kind of throw it down and it'll provide power to whatever it is you're trying to run. It's a lot easier to set that up than to work everything else. I mean, you can just let the generators run on an empty wire to see your research results. So you don't necessarily need to do all the electronics and stuff to get all that out. You could just use the dev generator. Pretty handy. All right, let's try this again. Let me add my gas thermal sensors real quick. We'll try this again, just like this. All right, so when these things go to start up, one of the things that I notice here is that all of this stuff down below can be in water, but the ones that are above it are not going to be in water, and those might be a problem. The way I had this set up, I was trying to only use one steam turbine. That way you don't have to make multiples of these, because each time you do that you have to have another power control station if you want to get all that bonus out of it. So it ends up taking quite a bit more space. There's some other things that I have going on here with the power system. I'm running a heavy watt joint plate between these two. The idea being that you could possibly pull a vacuum between this, which would, you wouldn't conduct heat across that joint. So if that was a vacuum right there and that was a vacuum right there, then it should be thermally isolated. Well, you can see the first problem here. These guys are getting too hot. So when we go to actually build this in like the real world instead of here in Sandbox, you probably want to use a bottle emptier to build up a little bit of water right here. Not a lot of water is going to stick on top of it because it's just going to want to flow off. But if you can get a little bit of water on there, that should kind of help to keep that heat down, and it might turn off into steam. And if you can kind of get these a little bit closer, then I think that'll work a little bit better. All right, so that's pretty close to a full line of hydrogen right there, but you can see that I don't quite have enough in this tank. This one has enough, but that one needs a little bit more. So here's where I'm going to turn this off, and what I can do is I can add a little bit more hydrogen to this loop. So I'll turn my gas pumps back on, pump in a little bit more hydrogen. You know what, just for the sake of it, let's fill these up. All right, so there we go. I have 2 full things of hydrogen. Boom. We're good to go. All right, so here's the neat thing about what's going on here. We do have a little bit of oxygen, possibly some mixed gas inside of here. However, these should get cold enough to the point of actually liquefying that oxygen so we can get rid of it. Of course, that means it's going to pump on over here, so might have to do kind of a filtering system on these 2 pumps in order to get rid of that. So if I had oxygen, let's say we have 10 kilograms of it, I just put in here. You can see that that's flowing around, and by the time it gets over here, that oxygen is going to start to cool down big time. So I want to see if this thing will self-clear. There we go, I saw a little bit of liquid oxygen. This pump is not quite in the liquid just yet, but as it gets down there at a rate around negative 190 degrees Celsius, we should see that that is dropping out. Here's another thing when it comes to running these thermal regulators. You can set them up on a power shutoff, just like this. So if you wanted to turn a whole piece of equipment off without messing with the automation on it, you can actually turn this thing on and off, just like that. So if these are just getting too hot, you can flick that thing on and off. Pretty simple. It's only going to run at half capacity, but that's one way to keep this top area from overheating until you have this nice steam everywhere and things even out. Alright, so we are getting some liquid over here, but this isn't actually able to pump out just yet. These liquid pumps themselves are a little bit too hot, so every time the liquid comes down, it touches the pump. There's a little bit of a heat transfer there, turns back into gas, so we kind of got to wait till those pumps chill a little bit. I decided to try a couple of mini liquid pumps down here as compared to one large pump. We'll see how that works out. It sure is taking a while. Okay, 1.92. There's a pretty good reason why it's taking so long. These little mini liquid pumps here, made out of plastic, actually have a fairly decent heat capacity, even when compared to something like this pump over here, made out of steel. Is what it is. Alright, so here's what I did to make my life a little bit easier. I just hooked these pumps up right here. We'll dump out the liquid oxygen once we actually get that up and running. And then you can deconstruct this, build that right over there like that, so that you run your methane over here and convert it into natural gas. Hey, there we go. Now I'm starting to see this work. These liquid pumps are now cold enough to actually not turn it into gas. So that is liquid oxygen flowing out of there. One of the other things I did here is I turned these down to negative 235 degrees Celsius. That again was from Ryu's comment over here saying you can run that. And it seems to be working. Nothing seems to be breaking. So, okay, so at this point we are actually pulling oxygen out of here. Although it's not ending up a vacuum very quickly. It's actually taking a long time. Alright, so here's what I could do to speed that up. Rather than having 2 tiles right there, I'll actually put a mechanized airlock right there. Boop. And then if I hook that up to a signal switch somewhere kind of remote so that I can get to it, what we can do is open that up and let these pumps do their thing. So that right there is open, and I have one of these, so we can actually pull a vacuum out of here. Now, one of the more interesting things about mechanized airlocks, and bunker doors is that they're all the same, thing, in that you when you put heat on this or cold on this, the whole thing heats up and cools down. So you can actually use this like a pretty big heat bridge or something like that. So all 500 kilograms of this thing will heat up and cool down together. So if you put in heat here and you're trying to like make that go from over here to over there, you can actually do it. Whether or not this will act a whole lot different because I have a door here rather than 3 tiles of gold, who's to know? Oh, pulling a vacuum here takes a long time. I'm gonna have to go ahead and just move on to the next step here, or you guys will never see this video. So here we go, bringing in a vacuum. We'll get it close. Let's see what happens if we have a little bit of mixed gases in here. So what I've got going on here with the crude oil is I'm going to bring that in right here. This is coming in at 76 degrees Celsius. And again, what I'm trying to do here is preheat that crude oil so that we gain a lot of efficiency that way. And this over here is just simulating something hot, right? Not necessarily the magma core, but I'm thinking more rockets, actually. Let's see how it does. So the crude oil goes in there, flashes, there we go. So now we've got some sour gas. All right, so since I didn't clear out the oxygen, you can actually see that I have a bit of a problem here. I ended up with mixed gases. So we have oxygen up top, natural gas, sour gas, all of that down here below. Not what I wanted, although it is technically still working. Let's see if I can pull off a trick where I filter that gas out. Like this. Aha! That was close. Does seem like you might want to pull a vacuum as soon as you can. Otherwise, you might end up with mixed gases. Yeah, I got this one little block of oxygen just floating all over the place. Doesn't know where to go. But you can definitely create a gas trap over here to kind of pull it out. So you can see I definitely have oxygen over there. And I can play with this door a little bit. Let's see here. See if I was able to get that out. Yeah, it looks like I was able to get the oxygen out of there. Interesting. Okay. So maybe if you had a door like this, with a spot where the gas could kind of go through there, that might allow you to kind of get that out and then trap it. And then you might be able to come back in here like this, deconstruct that, and then build through after you do something like that. All right, so now things are up and running as I would like them. So what I'm going to do is I'm going to go like that, and then I can disable that building. So now the liquid will flow, instead of down here, it will go up here. Haha, exactly where I wanted it to go. So once all of this is natural gas, what I should be able to do is, since that's connected, I should be able to kind of just get rid of that. It seems like disabling that doesn't necessarily let the gas flow the other direction, so I'll do that. Or wonder why in the world it isn't flowing. Oh, it's because I disconnected it up here. There we go. That's only going to flow if it's above 1,000. All right, so now things are starting to get up and running, hopefully quite well here. So if you start to take a look at the temperatures, you can see that the inlet over here, starting at 162, by the time we get here, we're actually still under 100 degrees Celsius. So everything's not heated up to the point where it needs to be yet. I'm going to go ahead and take this pressure now and bring it up. Let's go 5 kilograms, about twice as what we had before. So what I can see here with these tiles is that we are indeed absorbing some of that heat into the crude oil. So that's right around 240 degrees thus far. I do want to get it closer to 400 degrees Celsius. That way I only have to bump it up, well, about 150 degrees Celsius down here using this door. Ooh, now we're starting to see some steam. All right, good. You can see what I've done here with the natural gas generators using the mesh tiles to drip down on these thermal regulators. That way they stay cool rather than just being stuck in a pocket of gas that's getting real hot. Looks like we're definitely still a long ways from full power, so let's up the pressure a little bit more. 8,000. Ooh, look at that steam start to form. That's what I want to see. Crazy. Taking the pressure up once again to 12,000. This is further than the other system down here, right? Part of the reason I think I might be seeing a little bit more pressure on this one is because the run is quite a bit larger than what I had over here. And you know what? I mean, depending on where your heat sources are, you might have multiple heat sources. So you end up with a large column of sour gas flowing your way. One of the things I played with in the past was actually just having a door before the rest of this. So you can kind of build up as much sour gas over here as you want, sort of thing, and then open up a door to let it flow in to kind of your cooling system, and then monitor the pressure right here. That's another thing that we might be able to do. I forgot to get rid of all the carbon dioxide. Oh! That's what I didn't want to see happen. Stuff got too hot. Yeah, see, the temperatures here went over 400 degrees Celsius. Okay, so here's what's happening. The heat from here is traveling through the oxygen, which happens to be... I have a lot of oxygen in here. So I need to re-engineer this. Alright, so there we go. I put a little bit of petroleum in there. Figure out what heat that is. If it goes above 350, that should be a lot more safe. Because what was happening is that as the door was opening, the gas was filling in that void. And I was still getting thermal transfer between this plate and all of that. So that's why I was able to go above this sensor right there. So by using a liquid here, in this case petroleum, I should be able to get a much better control over that. Alright, so the next problem I have over here is I have oxygen building up down below. Although I have lots and lots of steam here. So really, what I might want to do on this side or that side is to allow that oxygen to get out of there. Using a triple door system is a pretty good way of doing this without letting out too much heat. Because I'm trying to get all the heat I can right here. This should be the hottest part. Alright, so that's where that steam turbine's located. That's why I put it way down here rather than way up here. Because I'm also bringing in this radiant gas pipe, which should have some relatively hot gas running through it. Because not only can I run the pipe here, honestly I should run it through over here as well. But I can open up this middle door here. That creates a vacuum between the two, so now the heat won't go through this area. So if I just do this number and open all of these up real quick, I should be able to let that oxygen flow out of there and let the steam push it out. Okay, well that's sort of working. Oh, there we go. Might make your base a little bit crispy for a little while. There we go. And then set that one to open. Good enough. Alright, so that natural gas is flowing back, but it's only about 100 and some degrees Celsius. I really want that to be a little bit hotter. So, even though I don't necessarily know where this is going to be, I think the idea is that you can take this and then run that radiant pipe right through this block as well. And then follow this back up right there. So now the heat that we pull out of here should be quite a bit more. There we go, 450 degrees Celsius, much better. So then when that gas goes through here, it's right there next to that steam turbine. Might get a little bit more juice out of it. Alright, so I'm just trying to tune in the final amount of pressure here that I can work with. But take a look at the temperature overlay real quick. You can see that by changing things around, kind of moving stuff, how much more efficient we're able to run this machine. So right on over here, you can see that the sour gas, even just above where we have the heating element, it's 375 degrees Celsius. Not really that bad. Matter of fact, the crude oil that's flowing in here, I mean, if we can even get it hot enough, we will possibly get it to right around 395 degrees Celsius. But for the most part, we're actually taking a lot of that heat right back out, just in the form of natural gas or by heating up the crude oil that's flowing in. So we're getting a big boost right there. This is only 360 degrees Celsius. By the time we're right on over here with what we're doing with the natural gas right there and the fact that the water from the steam turbine is running out right there, that sour gas is 140 degrees Celsius. Much, much cooler than where we were at beforehand. Matter of fact, by the time we get on over here, we're already at negative 30 degrees Celsius. So the speed at which this thing can run has really increased quite a bit. How much so? I don't really know. We'll have to let this run for a few cycles and tally up the results, but you can definitely see that I'm able to move quite a bit more through this system here than what I was able to do with kind of the previous setup right here. A lot of it has to do with that steam turbine, but also a lot of it just has to do with kind of how effectively I'm preheating all that crude oil. So the interesting thing about this is that I'm not using any more cooling capacity, so this is all gained from efficiency. Although you can see I was having a little bit of an issue there. Let's go ahead and fix that. That's why you run this stuff, to test it out. There you go. There might be a serious imbalance here. Let's see if I can fix that. Weird little improved weird thing that I'm trying out here is I'm creating little bumps right there. This way I could possibly capture the natural gas that kind of finds its way in here and floats around a little bit. Every once in a while I get a little pocket of natural gas floating around. Then again, it doesn't really seem to want to make up its mind where it wants to go. Yep, nope, there you go. Alright, so I've let this run for about as long as I can afford to let it run, and I think I've come pretty close to stabilizing the numbers, right around 7,000 over here. So 7 kilograms input temperature right there seems to average things out, although I think I still have a little bit more capacity left in it. So, but I don't have forever to run it. So I'm going to let this run for the next 5 cycles, collect the numbers, and see just how much we've improved. Oh, and here's one more thing that I'm going to add to this system. That is right here. Once we get over a certain pressure, I want to take the water out of here. So if I take a look at how much steam we have in here, so just like this little Atmos sensor, detecting how much pressure we have for steam, and then once it goes above that, then we scrape a little bit out. Technically, we might want to do this with lower pressure, but right now I'm kind of stable with the numbers I have right now, so I'm not going to worry about it. If we take a look at our inlet temperature for the crude oil, we're hitting 370 degrees Celsius, a little bit more than that. I've got this mechanized airlock set up just like so. It opens up if we ever go above 390. You can see that it kind of doesn't quite get there. It gets to right around 380 or so. It's about as high as it's going to get. I like that. I like that it isn't exploding on me. Little bumps right there. Those are capturing up the natural gas. That seems to be working pretty good. The temperatures here are looking real nice. Look at that. Ooh, look at that. Interesting results. All right, so these results are really quite interesting because they're better, but it doesn't necessarily equal a lot more sulfur. Think about that for a moment. So, for reference, here's the old system down here, the one I did last time, and those numbers was about 250 kilojoules per cycle, right around 400 watts, without a buff, or 1,050 kilojoules, right around 1,700 watts, with a buff. So if we take that and we compare it to the new system up here, the numbers change quite a bit. So this system up here, without any buffs, we went from 250 up to 601 average kilojoules per cycle, or right around 1,000 watts. So it's more efficient, and therefore we're getting a lot more out of this. Now, if you were to add in a buff, because we have these power control systems right here, so your dupes can go in there and tune things up, then that jumps all the way up to 1,500 kilojoules per cycle, or 2,500 watts. Not bad. So we're definitely producing a lot more power with this setup as compared to the last one. However, there's an interesting side effect to this. We're actually not producing that much more sulfur, which means we're not really moving that much more gas through this whole system. A lot of the benefits we're getting out of this is from efficiency gains. Interesting. Let's take a look at the numbers. So previously, we were getting around 81 kilograms of sulfur out per cycle, and the amount of oil that we were pumping into the system was about 250 kilograms. After a little bit of redesign here, we're now getting 93 kilograms of sulfur out, and we're only using, on average here, 280 kilograms of oil. So we've only got up 20 kilograms of oil. So by comparison, we're only using 12% more oil in our system. However, we're generating 75% more power. So there's been a definite improvement there. As far as the other things that we're getting out of this, we're getting a little bit more water. So this is now 141 kilograms per cycle and about 47 kilograms of carbon dioxide per cycle. So the cool thing about this system is that it's quite a bit more efficient than the last one. I think we've definitely made some improvements there. So much so that I would say I'm quite confident that I could build this in the game, actually get it up and running, and maybe not even use the power control stations if I don't want to. I've set up some things here to try to make it so that a dupe can get in and out of this area. So when they walk across here, they can pass through, and the door will close behind them, making that a nice little vacuum. They do their thing. Then when they go back out, they step on that platform for a little bit, and then the door cycles again. To take a closer look at that automation, all I'm doing here is a signal reset with a couple of filters. So when a dupe steps on this, it activates it, and it stays active for a short amount of time, and then it resets. the gas will still move through here. Whatever gas you have will still move through here when the dupe's moving through, but this way, less gets through. Okay, less gets through. As far as the generators, you know, I am running it just like this, but as it turns out, I think 6 is about the right number. You can see that as each chunk moves in here, it's all consumed by the time it gets to the last one there. So they don't run 100% all the time, but they all do run. So the neat thing about this is it gives you an option to kind of build up some natural gas and then run this if you have some heavier cycles where you need more power. Not that I would necessarily do that because I kind of like this whole thing to be stable and self-powering, but you could definitely do something like that. Steam turbine sits here and kind of runs about half power all the time, so that's actually working out really good. As far as the overall speed of this, we have bottomed out on the temperatures pretty much, so I'm thinking there's a little bit more that I could run in here. I'm not so sure that I would try to control the pressure way back here, especially if it was really, really far away, like hooked up to a bunch of rockets or something. I might try to throw in a door right here and then control the pressure downstream of this. You can see that right here, once we're finally getting into this system, it's right around 5 kilograms. I'll put a download to this save file down below if you kind of want to get in there, dig into it, and try to recreate it in your game. Also throw in some screenshots as well. So there you have it, a fairly potent sour gas boiler that doesn't require any sort of special materials. I think this has been a pretty neat little experiment. I didn't necessarily think a thermoregulator powered sour gas boiler thing was really going to work out all that well, but as it turns out, yeah, it is actually quite effective. At any rate, that's all I got time for today. Thank you guys for watching. If this looks like the channel for you, maybe consider hitting that subscribe button. Stay awesome, guys. Peace. Brothgar out.